Hello guys, how are you? I hope you will be fine. Welcome to my YouTube channel. Please subscribe and like this video. This video is related Polyglot Persistence. This video is very interesting. Let's start this video. Topics covered: disparate data storage needs, Polyglot data store usage, service usage over direct data store usage, expanding for better functionality, choosing the right technology, enterprise concerns with Polyglot persistence, deployment complexity. What is polyglot persistence? Polyglot persistence is the concept of using different data storage technologies to handle different data storage needs within a given software application. Polyglot programming, a term coined by Neil Ford in 2006, expresses the idea that computer applications should be written in a mix of different programming languages in order to take advantage of the fact that different languages are suitable for tackling different problems. Complex applications combine different types of problems, so picking the right language for each job may be more productive than trying to solve all aspects of the problem using a single language. This same concept can be applied to databases, that an application can communicate with different databases using each for what it is best at achieve an end goal. Hence the term polyglot persistence. There are numerous databases available to solve different problems using a single database to satisfy all of a program's requirements can result in a non-performance. For example, are good at enforcing relationships that exist between various data tables to discover a relationship or to find data from different tables that belong to the same object. An SQL join operation can be used. This might work when the data is smaller size but becomes problematic when the data involved grows larger. A graph database might solve the problem of relationships in case of big data, but it might not solve the problem of database transactions which are provided by RDBM systems. Instead, a NoSQL document database might be used to store unstructured data for that particular part of the problem. Thus, different problems are solved by different database systems, all within the same. Consistency: strong consistency, weak consistency, eventual consistency, coil consistency, read your rights consistency, session consistency, monotonic read consistency, monotonic write consistency. Three types of consistencies: strong consistency, after the update completeness any subsequent access by A, B or C will return the updated value. Weak consistency, the system does not guarantee that subsequent access will return the updated value. A number of conditions need to be met before the value will be returned. Often this condition is the passing of time, the period between the update and the moment when it is guaranteed that any observer will always see the updated value is dubbed the inconsistency window. Eventual consistency, the storage system guarantees that if no new updates are made to the object eventually after the inconsistency window closes, all access will return the last updated value. The most popular system that implements eventual consistency is DNS, the domain name system. Updates to a name are distributed according to configured pattern and in combination with time control catches. Eventually, of client will see the update. Why inconsistency? Inconsistency can be tolerated for two reasons: for improving read and write performance under highly concurrent conditions, and for handling partition cases where a majority model would render part of the system unavailable even though the nodes are up and running. Whether or not inconsistencies are acceptable depends on the client application. A specific popular case is a website scenario in which we can have the notion of user perceived consistency. The inconsistency window needs to be smaller than the time expected for the customer to return for the next page load. This allows for updates to propagate through the system before the next read is expected. Inconsistency window overlook. The system does not guarantee that subsequent accesses will return the updated value. A number of conditions need to be met before the value will be returned. Often this condition is the passing of time, the period between the updated and the moment when it is granted that any observer will always see the updated value is dubbed the inconsistency window. There are a number of variations on the eventual consistency model that are important to consider. Coil inconsistency: if process A has communicated to process B that it has updated a data item, a subsequent access by process B will return the updated value and a write is granted to supersede the earlier write. Access by process C that has no coil relationship to process A is subject to the normal eventual consistency rules. Read your writes consistency: this is an important model where process A, after it has updated a data item, always access the updated value and never will see an older value. This is a special case of the coil consistency. Session consistency: this is a practical version of the previous model where a process assesses the storage system in the context of the session. As long as the session exits the system guarantees. I hope you would like this video. Thanks for watching this video. Allah Hafiz.